Assalamu alaikum. Good afternoon. My name is Fatima Fuad and I'm from UKM and I'm studying at Information Technology. Today, I'm going to visit a new framework for authentication and key storage to secure 6LoWPAN. The last decades, technology advances in wireless sensor network become very important, and it's included in many fields, and has given impetus to the advancement of smart sensors. Therefore, many protocols has been introduced and used, such as Z-Wave, Wi-Fi, and 6LoWPAN. In this study, we are focusing on 6LoWPAN, which is established by Internet Engineering Task Force, and it's arose from the idea that even 6LoWPAN can be included in Internet of Things. And therefore, 6LoWPAN is used in various fields applications such as military, healthcare, smart home, and so on. Because of the broadcasting of the wireless sensor, attacker can be injected, redirected, or alerted the communication transmitted over the air. Therefore, there's a need for secure transmission. And considering that the nodes are restricted capabilities in terms of communication and competition, there's a prefer to use lightweight authentication and key agreement protocol for security. And because the lightweight authentication scheme used fewer resources, therefore there's a need for lightweight symmetric algorithm to achieve optimal power requirements while get the balance with the secure requirements or features such as authenticity, integrity, and confidentiality. So this solution can be increase the performance of wireless sensor network and improve the security, as discussed in many last researches. And even there's a new improvement for this field, there is some limitation still considered, such as the authentication and key management process and flexibility. So the main objective for authentication process is to ensure that the security of 6LoWPAN with good protection against mass attack and enhance the performance in terms of communication resources and computational overhead. So the contribution of our study first, proposed mutual authentication between sensor nodes and the gateway with the minimal competition overhead without compromising security credential. The second contribution is to use pre-distribution scheme and the track sequence number in the internalization phase to reduce multi-hop communication and protect against attacks. And the last contribution, it's use LICI algorithm to cipher is to encrypt and decrypt the keys with minimal memory requirements. So the design architecture of our framework that includes the end nodes, cluster head, and the gateway. So as we know, the end nodes collect the data from the surrounding environment and send it to the gateway via the cluster head. And we will do this, we will propose our scheme based in two phases. The first phase is centralization, and the second one is lightweight authentication and the key establishment. And we are considering the three characteristics or features: mutual authentication and confidentiality and integrity. And we will use using these notations in our framework. First, we'll start with the initialization phase that will use the key poll nouns and the transaction sequence number. So the end nodes start to send their ID. End nodes start to send their ID to the gateway. The gateway, they will create the key pool using pseudorandom function and the transaction sequence number, and send it back to the end node. Here we have two tables: table in the end node and table for the cluster table for the cluster head. To save their information like their key, their ID, and the transaction sequence number. The second phase is lightweight authentication and key distribution phase, distribution or establishment phase. They use here for messages or for flighted between the end node and cluster head and the gateway. And we use the session key sublution. They start first with the authentication, then will they generate the session key for start the securing communication. First we'll start here with the end node. The end node, they will start to create their key using the key ball that received from the gateway, XORed with the nouns. Then we'll calculate M and R and S. M use it to improve improve M and R and S to improve that they come from the trusted node and send it to the cluster head. Cluster head will verify the M to check if it's true or not, and then he will create his own key, which the same used from the key ball XORed with the nouns, and produce the M1. And M1 with the bare messages that come from the end node will encrypt in the G and send it to the gateway. In the gateway first, he will decrypt the G and check the M1 and the R and the S if they are correct. Based on their K and their ID, he will update the transequence in his table and the transequence for the end node and the cluster head. And then calculate M2, R2, and S2 and send the calculated messages with the transaction number and their key, send it back to the cluster head. In the cluster head, he will decrypt the G. He will decrypt the message come from the gateway and check if M2 is correct. Then he will update the transaction in his table and send M3, hash M3, and send it with R2 to the end node. And the end node, they will first check the M3 and R2, and he will update if they are succeed or correct. He will update the transaction sequence number in his table, and finally he will create the session key. The session key he will dynamically generated by XORed all the key used in the mutual authentication, and then send the session key back to the cluster head and the gateway. So Based on our CD, we will use for this framework, we use the Koja simulator, which is included in the contact key, and we will use it formal and informal security. We'll use for informal security AVSAB program, and for proof the logical correctness, we will use BAN logic. And this our framework will be compared with the LoWPAN and the QI protocol to prove they have better results in terms of communication and computation overheads. So we will improve the security and performance by reducing the communication and computation costs through symmetric, lightweight authentication-based key management. And this improvement will advance through the use of method based on hashing, redistribution key, track sequence, nouns, and symmetric LICI algorithm for both initialization and authentication. Thank you. And now I'm ready for your questions.